Section 3.5, parallel lines and triangles. Our objective for today is to use parallel lines to prove a theorem about triangles, also to find measures of angles of triangles. Make sure you copy postulate 3.2 into your notes. It has a name, so make sure you highlight it or star it, and then just put the very top sentence in there. Through a point not on a line, there is one and only one line parallel to the given line. Gives you a couple pictures and basically restates what they just said. Theorem 311, triangle angle sum theorem. This one, make sure you star or highlight. It is one that you'll use very often. The sum of the measures of the angles of a triangle is 180. I actually gave that to you last week. However, you didn't know what theorem or postulate it was, and now we're going to use it a lot. There's a proof of the triangle angle sum theorem that requires an auxiliary line. That's a line that you add to a diagram to help explain the relationships in proofs. So advanced students, you guys can watch this proof. Geometry students, you can skip to the next example. Triangle angle sum theorem is the proof that we're proving, so we cannot use that for a reason. We're given triangle ABC. We want to prove that the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180 degrees. Again, without using theorem 311, only the stuff that we've used before. So when you look at that red line that's drawn in the picture, that's that auxiliary line that they're talking about. We need it to help us carry through this proof. So it says draw line PR through B parallel to AC, and that's using the parallel postulate that we have in our notes. The next statement says the measure of angle PBC and angle 3 are supplementary. So the measure of angle PBC is this one right here, and I'm going to change colors real quick. So PBC, that's this one right here. Now, if you guys were doing this one on your own, I don't know that you would come up with that at this point. But if you look at it, this angle that I have highlighted in green plus this one are supplementary. They do form a linear pair. I'm going to say either definition of linear pair or, like the book says, angles that form a linear pair are supplementary. And again, I said definition, linear pair could work as well. Okay, let's move on a little bit. The next reason given is definition of supplementary. So in the reason before, we mentioned that PBC and angle 3 are supplementary. Well, what does that mean? It means, let's say that they are, in that they add to 180 degrees. So measure of angle PBC plus the measure of angle 3 is equal to 180 degrees. Okay, angle addition postulate, that means taking the small parts, adding them together, and set it equal to the large part. So what two angles make up angle PBC? It's angle 1 and angle 2. So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle PBC. And that again is just taking these two smaller parts, this one plus this one is equal to the large part that we have in there. The next one is substitution. So what do we have? PBC, we're going to use these two statements in order to get this next one. So PBC is now measure of angle 1 plus measure of angle 2. So we are putting that in for angle PBC. What was already there was measure of angle 3, and it equals 180 degrees. So we have substitute that in and made it a little bit simpler. The next statement says angle 1 is congruent to angle A. So if we zip up and look at the picture, Now I'm going to erase what we have, and I'll kind of mark this one out. So we have two parallel lines. Here's one of them. Here's the other. If we extend this one, notice that angle 1 and angle A are alternate interior angles. And on the flip side, if we use these two parallel lines once again, and this one, oops, I missed that line there. Angle 3 and angle C are the same. So that's what we're going to write in the next, and that's why they're saying that. So we're going to say alternate interior angle theorem. The reason it's just the basic theorem is because we already know that those lines are parallel because they gave us that triangle up there, and they talked about the parallel postulate already. So we're going to say alternate interior theorem. Okay. Definition of congruent. We are going to convert congruent symbols to equals so that we can use them together. Measure of angle 1 is equal to measure of angle A, and measure of angle 3 is equal to measure of angle C. Definition of congruent. Okay, well, how can we use those together to get to the end? We can substitute in for those things that we need. So measure of angle 1, okay, I'm going to change colors once again here so you can see where I'm looking. So I am using this statement right here and these two statements right here to get to this last one. Measure of angle 1 is the same as measure of angle A, so I'm going to plug that one in. Measure of angle 2 stays the way it is. And the measure of angle 3 is now measure of angle C. And that's what we were looking for, and that is substitution. So kind of a complicated proof, but one that is a good thing to notice different things, where you go, what lines you use, and kind of look at it in that way. So geometry students and advanced geometry students, here's the next problem that we're going to solve together. What are the values of x, y, and z in the diagram? So notice that we have actually 3 triangles. We have the small triangle, which looks like this. We have the triangle on the right. And sometimes splitting them apart helps you to see where you can start. And we have the large triangle as well. So here, this would be 43 plus 49. So when you're looking at them, the only one that you cannot do right away is this one right here. Can't start here. And the reason is because you've got 2 variables in there. Okay, 2 variables is the reason why you can't start here. So look at the small triangle, 59, 43, and x. There's only one missing. We can start with that one. So I'm going to start with this one, 59 plus 43 plus x is equal to 180. So if we subtract 59 and 43 from 180, we get 78. And we can also start here, same thing, 59 plus 43 plus 49. You can do a total there if you want to, plus z equals 180. So I'm going to take 180 and I'm going to subtract 59 and 43 and 49, and I get 29. And then I also have to go back and find the other. So now that I know that z is 29, I can substitute it in there. So 49 plus y plus 29 is equal to 180. So y is equal to, oops, I missed a number. 180 minus 49 minus 29 is 102. So in this particular triangle, it's all about looking at what you have. Don't look at it all at once. Break out the triangles and see where you can start and move along to figure out what is the easiest for you to do. An exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side. So when you look at each of these angle ones, it extends one of the sides out. So this right here is an exterior angle. Notice how this is an extension of this side. Again, angle 1 is an exterior angle there as well. And then if you extend on the right side, angle 1 is an exterior angle here as well. So all of my green stars are exterior angles. A remote interior angle are the two non-adjacent interior angles to the exterior angle. So I'm going to mark these in purple. So if this right here is an exterior angle, this one and this one are remote interior angles. Notice it's the only one that is not here, because that's supplementary. It can't be a remote angle and a supplementary angle all at the same time. So if you start with the exterior angle, this is the one that it is not. This is an exterior, so is this one. Or remote interior, sorry. Start with the exterior angle. It is not the one that is next to it. It is the other two angles. And remote, remember, means far away or furthest away. So it's not the one that's next to one, it's the two that are furthest away. In the next theorem, we'll see a little formula. Theorem 312, make sure you put this in your postulates and theorems. It's triangle exterior angle theorem. And if you want to just put the formula here, you're okay. But if you put the formula, make sure you draw the picture. You can do the words or the formula and picture. Let's try it. It says the one on the outside is equal to the two remote interior angles added together. So 1 is the exterior angle, so it's measure of angle 1 is equal to 80 plus 18, because those are the remote interior angles. So the measure of angle 1 equals 98. Okay, let's look at another one. Here is the exterior angle. Here are the remote interiors that you add together. So this one looks a little different. 124 is equal to 59 plus the measure of angle 2. So we subtract 59 from 124. And we get 65. Now, that's using the remote interior angle theorem. What do you do if you forget that there's a theorem out there, or you're one of those people that refuse to write down the theorems and look at them? Here's another way to do this one. All right, so on this one, if we knew that angles of a triangle add up to 180, we could find out this missing one first. 80 plus 18 plus, I'll call it x, equals 180. So 180 minus 98 is 82. Okay, so if I change that into an 82 instead, now note that these two are supplementary or linear pair. 82 plus measure of angle 1 equals 180. The measure of angle 1 would be 180 minus 82, which is 98. And notice they are the same. Same with this one, except you're going to do it in reverse order. So what we're going to do is we're going to start here, and we're going to say, I want to know what x is first. 124 plus x equals 180 because they are supplementary / linear pair. 180 minus 124 is 56. Now that we know that, we can substitute it in. 56 plus 59 plus the measure of angle 2 is equal to 180. The measure of angle 2 would be 180 minus 56 minus 59, or 65. And again, same answers. Takes a little longer to get to the answer, but it does work. So keep that in mind also. Got a question. 2 angles of a triangle measure 53. What is the measure of an exterior angle at each vertex of the triangle? Got a question. 2 angles of a triangle measure 53. So draw a triangle. It really doesn't matter where you put them. I'm going to pick the acute angles. What is the measure of an exterior angle at each vertex of the triangle? So what you do is you extend each of the edges. So we'll call this one X. We'll extend this one. We'll call this one Y. And we'll extend this one. It doesn't matter what way you extend it to. We'll call this one Z. So first of all, 180 minus 53 minus 53 would be that missing angle at the top, which is 74. And then 53 plus x equals 180. So x would be 180 minus 53, or 127. Okay, so this is 127. This one is also 127 because it's the same angle. And 180 minus 74 is 106. Okay, now let's back up and use that exterior angle theorem also to show you that you do get the same answer. So if you're looking for this exterior angle, you're going to add 53 plus 53. So y equals 106. If you're going to do this one, you're going to do z equals 74 plus 53, which would be 127. And then, of course, if you're going to do this one, it actually matches your z because it is the same angle. So it would be, again, 74 plus 53. So exterior angle theorem makes it much easier because it's not a two-step thing, it's just one, but you choose what you want to do. The only reason that you would run into trouble if you didn't use it is if these numbers that we were given at the beginning were variable expressions, then you would have to use the exterior angle theorem because I don't know that you would be able to find it otherwise. So it makes it much harder if you don't use it. When radar tracks an object, the reflection of signals off the ground can result in clutter. The clutter causes the receiver to confuse the real object with its reflection, called the ghost. In the picture below, there's a radar receiver at A. That's right here. An airplane at B. And an airplane's ghost at D. What is the value of X? So when you're looking at it, you're looking at a triangle. 80 is the exterior angle. 30 and X are the remote interior angles. And if you subtract 30, you get X equals 50. And that is what you're looking for. And that's it. So kind of a little bit longer video, but the equation is not hard to use. So come with questions on Monday.